Hi everyone, this is a look at molar mass. Molar mass is one of the most important things that we need to be able to determine in chemistry. We need to be able to do it routinely. We're going to do it all of the time, literally all the time. Molar mass represents the mass in grams of 1 mole of a substance. This means that it has the units grams per mole, g/mole. Basically what we need to do is count up the atoms in a formula, use the data booklet or our memory and think about the individual atomic masses, and then work out the total. If we ever encounter molar mass in a formula, it has the symbol capital M. Here's 3 examples. First one is water, H2O. When I look at that formula, I need to be able to, what am I saying over here? Count up the atoms. H2O, no brainer, it has 2 hydrogens and 1 oxygen. Then I look up the individual atomic masses in the data booklet. Hydrogen is 1.01 and oxygen is 16. Now I need to just add all those up. 2 hydrogens, 1.01 each, 1 oxygen at 16. When I do the math and work all that out, it turns out to be 18.02 grams per mole. 1.01 plus 1.01 plus 16. 18.02 grams per mole. That's the molar mass of water. A second example, C3H8. That's propane. It has 3 carbons in it. When I look up the atomic mass in the data book, it tells me that carbon has a mass of 12.01. And there's 8 hydrogens, H8. The periodic table tells me 1.01. So I just need to do the math, count 12.01 3 times. There's 3 carbons and each of them is 12.01. So I'm typing that in. And there's 8 hydrogens. Each of them 1.01. When I do the math there, I arrive at 44.11 and the units grams per mole. That's the molar mass of propane, C3H8. One last example, here I have magnesium nitrate. Here I have to be slightly more careful when I'm counting up the atoms. There's 1 magnesium. The periodic table tells me the mass of magnesium 24.31. Look at that, there's 2 NO3s. That means 2 nitrogens. Each of them at 14.01 grams per mole. And here I'm going to multiply. There's NO3 twice, and that means it represents 6 oxygens, 6 O's, and the data booklet tells me that they have a mass of 16.00 each. So, slightly more involved calculation this time, but I'm going to say 24.31 one time, 14.01 twice, and 6 sixteenths. And I find 148.33 grams per mole. Molar mass is one of the most important things that we need to be able to determine throughout the whole course of the term. We need to be able to do it routinely. In the beginning, we might really need to take our time, but as our confidence level increases, as we do so many of them, we're going to get faster and faster and faster. In the end, what we really want to be able to do is go from a formula without writing anything down and go directly to the molar mass, just using our calculator and the data booklet. And I hope that helps.